This is Temple Chemistry Demonstrated. My name's Skylar Patton. I'm the chemistry faculty member that gets to show you chemistry. Today we're going to talk about fluids. Fluids. Liquid is commonly the first thing that comes to mind with fluid, but by definition, a fluid is something, a substance, that can flow. Gases flow. They do. You've seen it many times before, you just might not have looked at it that way. That flame takes that shape because the oxygen comes in, it reacts, it's hotter, it comes up here. You can't see that. 1925 in Texas, it was a company that made solid carbon dioxide. They called it dry ice. We call it dry ice. It's still solid carbon dioxide. It has a sublimation point of negative 79.5 Celsius or negative 109 Fahrenheit. So I'm not going to use my bare hands on this. I'm just going to put it in some room temperature water. That's a lot hotter than this sublimation point. Oh, sublimation point? At regular pressure, carbon dioxide does not like to do the liquid state. It's solid, but above that point, it doesn't even do liquid. It would just rather be a gas. Carbon dioxide. Oh, carbon dioxide. That's like the stuff that's in fire extinguishers. I should be able to put this flame out, right? Just going to pour this carbon dioxide right on top of it here, right? It's not blowing out the candle because the gas that you can't see flowing are the ones coming up here. Let's attack it from the side. Just happen to have this ramp like right here. Gases are fluids too. With that carbon dioxide gas coming down, because it's more dense than the air around it. 44 grams per mole, the air around us is about 29 grams per mole. It came down and it pushed the wax vapor and the oxygen apart from the spark. That's what we call blowing out a flame. Let's light this candle again and pour a different gas down the ramp. What I have are called, well, hexanes. The plural part we'll worry about a different time. Hexanes, 6 carbons, and then hydrogens all around, so carbon gets its 4 bonds happily. That makes 14 hydrogens. That means 86 grams per mole. Practically twice the density, remember how gases are, of carbon dioxide, 3 times or more, about 3 times, the density of air. But one big difference, we can't see that vapor. How do we even know it's there? It's volatile. Volatile means it's prone to change. It's in its liquid state, but it's really close to becoming a gas state. I can smell this. That's one way that I know it's volatile. I'm going to assume, temporarily, that there's just hexane vapors in here, but we can't see them until you can. Not pouring the liquid, just the vapor part. Oh, that vapor found its way down the ramp, hit the flame, and did quite the opposite of what carbon dioxide did and ignited, producing carbon dioxide gas and water vapor, because that's what always happens when hydrocarbons combust. They get oxidized. Gases are fluids because they're substances that can flow. Sometimes we can control that flow and have some fun with them. I'm Skylar Patton with Temple Chemistry Demonstrated. Thank you for watching. Stay tuned for more.